Hey Fraser, how are you?
Very well, thank you so much.
What were you like as a kid, and where did you grow up?
I grew up on Vancouver Island, Canada, which is a fairly big island off the coast, the western coast of Canada. And man, I was the same. I think when people watch my videos, they get the sense that I'm very curious. And that was me as a kid. Like, I just kept asking questions forever. And I'm sure I wore my parents out on how many times I asked how curious I was about everything. But I was really lucky with my parents. They were both quite scientific minded. They were both into space and science fiction and astronomy. And so I got a chance, I lived in a place with very dark skies.
Oh,
and so
great.
I was able to see the Milky Way and able to see meteor showers and lunar eclipses and all kinds of stuff. And so it was great to have, my one memory that I have is that my father woke me up at like 5 a.m. so that in 1981, so we could watch the launch of the space shuttle for the first time.
Wow.
So it's sort of like space, but I was already obsessed about space even at that time.
Really? You were a stargazer as a little one.
Yeah,
Great.
I bought my own. I kind of obsessed and bought my own telescope when I was 14 years old. I did space journalism in my high school. Like, I would join the journalism program and I wrote about space and astronomy for our newspaper. So I was just always into space.
So cool. So could you share with me about your beginning and how did you become a space communicator and a space research reporter?
Yeah. So I was like, weirdly, after I went to university for engineering, and then I left that for computer science, and I went and joined a company in Vancouver, like in 1995. And we were built like at the very beginning of the internet, and we were building websites for big corporate clients, banks, things like that.
Cool.
And I had a lot of ideas. I had all the crazy ideas, and my customers were nervous and they wanted me to have some experience with this. So I was like, okay, well, I'm going to experiment on myself. So I'm going to pick one of my hobbies and I'm going to build a website and then manage that website. And like, I was into mountain biking and hiking and video games and space. I'm like, well, space is the one that I want to learn more about. And they always say, like, you learn by teaching. And so I was like, well, I'm going to write about space as I learn. Mm-hmm. And then from there, I'm going to be able to also learn about how to run a website. And so I was able to practice all these ideas about building a website. And then I was able to give this advice to my customers, and it was really good. Like, I had good ideas, like that. Yeah. I learned that you have to update your website a lot, that people are going to email you and you have to respond to the emails, like all these kinds of things. And so I was able to provide really good value, and we were able to make some really great websites. But at the same time, I'm like, I really just want to do this. Like, I really am enjoying communicating space and astronomy, and it sort of connected back to the things that I was doing as a kid. And so now it's just a matter of like, when can I leave my day job and have this be my only job?
So cool. Can I ask you a personal question? Mm-hmm. Do you believe there is intelligent life in the universe?
I'm guessing you're asking this question because you know the answer, what I think, but
I do.
But no, I don't. There's this idea of the Fermi paradox, that the universe is big and the universe is old, and we have, life has had plenty of time to evolve everywhere across the universe. And more than that, intelligent civilizations have had time to evolve. And when we think about the future of humanity, like, we're now at the point where we're starting to explore the solar system. But in a couple hundred years, we will start to reach out to other star systems. And so we would expect that other civilizations have done the same thing. And yet when we look out into the universe, it looks like a pristine wilderness everywhere that you look. And people have all of these, I've spent 2 hours explaining my position on this. So, I'm not sure I can go through the whole process right here, but
sure.
But just like the analogy to use is to look out your window or pick up a board and notice that there's spiders underneath. And, the Earth is gigantic, and yet you have spiders just a couple of feet away from you. And that's because life wants to move outward and explore and exploit every single place that it can. And
yes,
we don't see that. We don't see life in the universe following that process. And yet we know, give us another 1,000 years and we will be everywhere. And the aliens out there will be like, we know there are other civilizations in the universe because we see what those apes are doing.
Yeah.
As they're conquering more and more of the Milky Way. So, there are, but everyone who's listening to this is going to have a million. Yeah, but maybe it's just, and sure. I promise you, just research the Fermi. If this fascinates you, research the Fermi paradox. And so my feeling is that because we don't see anything out there, then we're alone. Or we're first, which has a nicer sound to it. The more kind of horrible possibility is that something awful happens to every civilization as it reaches a certain level of technology. And I'm just going to pretend that's not true, and just go with. I much prefer that we're first, not we're doomed.
I couldn't agree more. Please, what do you expect from SpaceX after the first launch of the Starship on the biggest rocket right now in the world? And I know if it didn't go how we hoped, but it's a step forward. So what is your take on what happened on the launch? And what
it was
is the
dramatic.
Future?
okay. That's okay.
This is the right trajectory. Oh,
look at
God.
that! Oh! No way!
Oh, sorry.
No, we can jump. We don't have cameras up here. We can go crazy! No way! Look at that! Oh my God!
It looks like the right there.
Yeah, that was quite a launch. I mean, we saw the thing take off, clear the launch tower. Several of its engines weren't working. And then as it sort of got farther into the process, it started to roll. And then SpaceX pressed the button and detonated the rocket. And when you look at the pictures afterwards, you can see there's just this gigantic crater. Big parts of the launch tower have, are completely undermined by the power of that rocket. I mean, there was boulders, chunks of rock flying thousands of feet away. The nearby town, everybody got sand all over their houses. Like it's a very powerful rocket, and they were not prepared. And it looks like probably as the rocket was launching, it was causing damage to the rocket itself from all of this concrete blasting up and hitting the engines and things like that. And so it was kind of doomed from the beginning. It might have worked if they had been able to divert the flame away. And in fact, Elon Musk had said a couple of years ago that we're not going to build a flame diverter, and that might be might regret that. And he now, I'm sure, is regretting not building a proper flame diversion system. So they're going to have to come back around, and they're going to have to build a gigantic flame diverter system with some kind of water suppression that removes the sound and heat away from the rocket and the launch facility and lets this rocket get off the pad. I mean, if their plan is to launch this thing multiple times a day from this facility, it has to be capable of handling anything. So I think, the test of the rocket, I mean, they learned a ton about the rocket. They learned how the engines work. They learned, it reached max Q, so the maximum dynamic pressure. So a lot of their boxes were checked. It didn't go to orbit, which is too bad, because that is like really the big question that a lot of us have is like, can this thing come back from space? But the most precious part of this whole system, what they call stage 0, the launch complex, was damaged pretty badly. And so even though they could be ready to launch and test other starships, they're going to need months and months and months to repair and upgrade the system. So that's what we're going to have to be watching now, is as they get the whole system back in order, then we'll know they'll be able to launch again.
How many Raptors again?
Well, it has 33 Raptors on the super heavy stage, and it looks like 5 of them failed. Like 3 failed right away, like weren't even working off the launch pad, and then another 2 failed early on in the flight. So 5 of them were down, and it's amazing that it even got that far with 5 Raptors down. Like it's a beast of a rocket.
Yeah, it's so great rocket, even bigger than Saturn V, right?
Yeah, twice the power of Saturn V.
Wow, I'm so interested in everything Gaia does. What can you say about this space telescope, and what do you think? How long are we going to take data from Gaia telescope?
Yeah, I 100% agree with you. Gaia, like I go into this a lot on my channel, that Gaia is easily one of my favorite spacecraft out there. Too. And it is a astrometry mission. So what it's doing is relatively simple. It's watching this big chunk of the sky, and it's measuring the position and movements of all of the stars that it can see in the sky. And it's just doing this day after day, month after month, year after year, and slowly building up. And what it's doing is it's mapped about 1 billion stars, more than that, in the Milky Way, which is about 1% of the stars in the Milky Way, as well as the movements of many of those stars. Because like when we look up in space and we see the stars, they appear just to be fixed. But if you came back 100,000 years from now and looked at the sky again, the stars would all be in different places, because the sun is moving in the Milky Way and all of these stars are moving around. And Gaia is able to measure that and chart both the past and future of all of these stars. But what this has allowed astronomers to do is search for things. So in the olden days, you would say you wanted to find a white dwarf. You would observe a little area of the sky and you'd search for a white dwarf. And if you found one, you'd be like, we found one. What Gaia does is it just tells you where they all are, all the white dwarfs. And so you can dig through the Gaia data and then examine 1,000 white dwarfs simultaneously, because you just search for them. And so its ability to provide, like, it is like instead of you opening up a book one at a time and going like, is the recipe in here that I want to make for dinner? You instead have Google, right? That you search the entire internet, and that is the difference between what Gaia does. And they've done their third data release where they've released all this information about all these stars, their chemical composition, their movements. And they've also found a lot of other really unusual things, extra galaxies, quasars, things like that. But they've also found planets, because when a star has a planet orbiting around it, the planet makes the star do this little circle in the sky. And so you've got this star making these little spirals instead of just a smooth movement as they go by. And astronomers have been able to find planets. And when we see the next big Gaia release, it's believed that there will be thousands, if not tens of thousands, of planet candidates in that data. So suddenly the number of planets that we know of will double, triple, quadruple, and that'll come with the fourth data release.
I just love the telescope. I just hope it will work a long time. Do you think humanity will ever break the problem of interstellar voyage? I know about all known solutions for now. Are there any new ways for propulsion and some new science for this that you know of?
Well, I mean, we know that it's possible because we see rocks do it. Like astronomers discovered Oumuamua and Comet Borisov, which are two interstellar objects. These were objects that were formed in other solar systems, and they made the long journey from one star system to another. The Voyager spacecraft are leaving the solar system. It's going to take them 50,000 years to get the distance to Alpha Centauri. They're not going in the right direction, but if you pointed them at Alpha Centauri and you waited 50,000 years, then we would have reached another star system. So the question really isn't, can we do this? We know we can do this. The question is, are we patient enough? Can we do this fast enough that makes us happy? And that's a different question. And so there's a couple of ways to go about this. One is to be patient and wait. And there are times when stars, we talked about Gaia, there are times when stars will drift close to us, and we will be able to see that, now suddenly the star is only 3,000 years travel away by the Voyagers. There's one coming within about a million, in a million years from now, one star will come really close to us, and this happens all the time. So the one thing is just be patient. Like, instead of trying to get out to the universe, just wait for the universe to come to you. The other thing is that we are developing faster and more capable methods of travel, and the main one. If you've been following this, right? I mean, there are very few technologies that we understand today that will get you up to the kinds of speeds that will allow you to cross interstellar distances in a human lifetime. Like, there's really maybe one that we understand fairly well, which is to use a laser sail, to have a really powerful laser shoot a solar sail and increase its velocity up to 20% the speed of light. And then the other way is using antimatter. That antimatter, if we can make enough antimatter, it has the kind of energy density to get you to those kinds of velocities. Nothing else really covered. Like, if fusion drives won't work, fission drives won't work, chemical rockets definitely won't work, ion engines won't work. Like, you need something that is close to the speed of light for you to be able to achieve those kinds of velocities. So until we can either prove that these laser sails work, or we can manufacture antimatter at large quantities and prove that we can contain it and prove that we can turn it into energy, we're not going to be able to get out to other star systems.
So you don't believe in Alcubierre propulsion drive?
No, I mean,
idea?
I'm just a journalist, so I'm not the problem with Alcubierre, as I understand it, is that it requires negative mass. And that's not a thing that exists. So this warp drive works great if this thing that doesn't seem to exist according to the laws of physics exists. So step one, prove that, make the thing that doesn't seem to be possible to exist, and then step 2, build your warp drive. So, I mean, obviously, we can never be certain about what the future holds, and we would never want to be so arrogant to say, oh, we can never do this.
Sure.
But and as soon as we learn new laws of physics, we will be able to update our understanding of what is possible. But right now, based on what we know, it doesn't seem to be possible. And as soon as we learn new things, then we can change what is possible.
Sure. After more than 70 years, we are going to the moon. We need to stay on the moon this time for many reasons. What about the Artemis program? Are we going to put our feet on the moon soon? And do you think that the international moon base is foreseeable?
Yeah, I think we saw the first test of Artemis 1 and everything went great. We're in the process, NASA's in the process of preparing for Artemis 2, which will launch at the end of 2024. Mm-hmm. And then you're going to see Artemis 3, probably 2026, which will bring humans back to the surface of the moon. But there are probably another 8 Artemis missions planned beyond Artemis 3. And the long-term plan is to build a base on the moon. Like we have the International Space Station, there will be a time about 10 years from now when you can look up at the moon and there will be humans there. And there will be always humans there from this point forward. There will always be humans orbiting Earth in a space station, or 10. And there will always be humans at the moon. And eventually, next comes Mars, and there will be a research base on Mars, and there will be a time when you look in the sky and you see the International Space Station fly overhead, and you see the moon, and you see Mars, and you're like, there are people in all of those places right now.
Sounds great, really great. We are waiting for the great ground telescopes like Vera Rubin Observatory to come online. Do you think those telescopes and technology in them is going to help us see more? And what are we going to be able to see that we can't see right now?
I mean, yes, these telescopes are so big, it's hard to wrap your mind around it. Vera Rubin, for example, is the size of the biggest telescopes on Earth, but it has the biggest digital camera that's ever been made. It's like a 4 gigapixel camera. I forget the size. It's bonkers how big it is.
Enormous.
Yeah, and it will be able to scan the entire night sky every 3 nights. So it'll take a picture. Seconds later, it'll take another picture. Seconds later, it'll take another picture. And each one of those pictures is this really deep, really sensitive image of the sky. And it will just do this over and over and over again. And suddenly we will see, imagine you took one of the biggest telescopes on Earth and you looked at this one little spot in the sky for hours and hours, and you found some stars and found some quasars. Well, Vera Rubin will do the whole sky at that level of depth. It's the thing that will find all of the asteroids out there. It'll find all the comets. It'll find Planet 9 if it's out there. It'll detect. Like we know of about 1,500 Type 1a supernova that have happened since 1998. So a certain kind of supernova. Vera Rubin will find 1 million. So it's just next level, and and so Vera Rubin is all about speed. It's kind of the same thing as Gaia, where you kind of go like, show me all the supernova, and then you find 1 million examples of supernova that happened. But it is tiny compared to the other big telescopes. So there's the Giant Magellan. Is it the Giant Magellan telescope? Anyway, the GMT, which is going to be a 33 meter telescope, and then there's going to be the European Extremely Large Telescope, which is a 39 meter telescope. And so just like to give you, right, like the biggest telescopes that we have on Earth right now are 10 meters across. And so this thing is going to be just stupidly big. And its job, like it's like James Webb Space Telescope, its job is to look at anything you want. Like you can look at stars, you can look at galaxies, you can look at quasars, you can look inside the solar system, you can do whatever you want. But it's designed to be sensitive enough that it could observe a planet like Earth orbiting around a star like the sun and just see the planet. Now, it won't see anything other than just a single pixel, but it still will be, you can learn a tremendous amount from a single pixel. You can learn about the chemistry of the atmosphere, the size of the planet, whether or not it has oceans or not. Like, there's a lot you can learn from one single pixel. And that comes online in 2026. So we are really just, and then there's the 30-meter telescope as well, which is possibly, has been kind of delayed, but in the next, say, 5 years, we could have 4 new monster telescopes come online and revolutionize our understanding of the night sky.
I love the segment of your show called Space Bites, where people can learn many things about the universe. How big is your team, and are they all into space exploration?
So for the Space Bites, it's me and my producer Anton. So he does the editing and some of the behind the scenes production. We figure out what the stories are going to be, and then I research the stories, and then I don't write a script. I freeform the news. And then we also have another video editor that works with us, Chad. And then we have about another 12 to 15 writers at Universe Today who are creating the stories on the website, like all of the text.
Oh yeah, I'm reading a lot from Universe Today, so it's really great. Everything I know, every new thing I know, it's from Universe Today and your channel. Yeah.
Thank you.
Please, would you share with me what are your favorite movies about space? Anything about space?
I'm sure you have the same situation too, where you know too much, and so you watch a movie about space. Like if I watch like Star Wars or Star Trek, the science is so bad, and the science is it's just magic that I just turn that part of my brain off. And I'm more interested in the story and the adventures and the characters and the action.
Of course.
I don't really care about whether or not it's set in space or not. Like it could be a pirate show for all I care, or a World War II military show. Like I don't really care. There are a couple of shows that have done a really good job. I would say the two best are The Expanse, which is an idea of like humanity a couple of 100 years from now. They've invented fusion drives and they're able to start exploring the solar system, and you've got these political factions between the Earth people, the Mars people, and the people who live in the asteroid belt. And the science is really good. I mean, there's a few things that they've made up to be kind of magical, but everything else is really good. And the stories are great. And so, the Expanse television show is terrific. And then the other one is For All Mankind, which
I love it.
Yeah. So there's the idea of like, what if the Soviets landed on the moon before the Americans did, and it kicked off a new space race on who could, like they just kept racing into space, building a base on the moon and sending humans to Mars, but the science on it and the depiction of how NASA works is perfect. Like it's just perfect. Like I watch this show and I can't find problems with it. And yet the story is also compelling, and the characters are great, and the action sequence are wonderful.
Yeah.
And every part of it is top notch. So I think I would say For All Mankind is the best space related show that's ever been made. And the more you know about space, the more you appreciate it because of how good of a job they've done in incorporating various technologies that could have flown but never did. And no, it's terrific.
Couldn't agree more. I love it. I can't wait for the next season. James Webb Telescope is in focus. While Hubble telescopes still makes breakthroughs, what do you think is going to be the greatest James Webb discovery?
Well, I mean, the wonderful thing about this is that we don't know. I mean, we don't know. We didn't expect some of the amazing discoveries that were made by the Hubble Space Telescope.
Yeah.
About seeing forming exoplanets. It helped discover the first exoplanet. It's looked deeper into the universe than we ever thought. It helped map out the structure of the universe. Like a lot of really fundamental questions about cosmology were answered by the Hubble Space Telescope. And with James Webb, I mean, it has these purposes. Its job is to look out to the edge of the observable universe and see some of the first galaxies that were ever forming. Its job is to look into stellar nebula and see new stars and new planets forming.
Yeah.
So, but we don't know, and that's the whole point. I mean, that's how science works: is that you follow your curiosity and you check and you look for things, and then you make observations, and then from there you start to try and figure out what it is that you're actually looking at. And I think that we just don't know. We don't know, and that's what makes it so exciting.
Yeah,
we don't know what we're going to find. And already, I mean, the fact that they're seeing these galaxies that are bigger and more mature at the beginning of the universe tells us that we have this incomplete understanding of how the universe works, which is really exciting.
Yes, we really live in exciting times. For the end of this episode, until the next, what would you say to people who are getting into this field, astronomy, astrophotography, or anything else relating to cosmos?
Well, I mean, I think everybody loves space, and it's quite amazing that you talk to people at a party and you talk about space, and everybody wants to talk about space. Like nobody hates space. They may have disagreements about it, but it's just this common thing that unites all of us. And there are some really wonderful ways that you can take this hobby further. Buying a pair of binoculars, getting a small telescope is great. Starting to learn the night sky so that you can see the objects, and when you see the planets are in the sky, you can point your telescope at them, and they're relatively inexpensive to buy. And if you can't even afford to buy a telescope, you can build one. I mean, it's possible. You can find plans on the internet on how to build a telescope out of parts that you have around the house. And at the same time, astronomy is one of those fields that amateurs regularly make contributions to the science. And so professional astronomers are looking for help to make observations, to confirm new planets, find variable stars. Like there's a lot of work that amateurs can do. Yeah. And I think for a lot of people, they love space. And then they kind of go like, oh, I really wish that I had gone to university to become an astronomer, or I wish that I had. Right. And is it too late? But the thing is that you probably don't want to be an astronomer. You probably don't want that to be your job. There's not a lot of jobs. They don't pay very well. There's, like one position for every 100 people, but it's never too late to learn about space. That you can go online and you can take courses about astronomy that will teach you everything that you could possibly want to know. And then you can build or buy a telescope, and then you can make observations, and you can discover comets and have them named after you. You can discover asteroids and name them, and you can confirm the existence of planets or even discover new planets. And all of this can be done just one step after another. So I think if you love space, and if you have this itch that you need to scratch, that you're like, I really wish that I could do more space, that I wish I could live that dream of childhood me, it's still available to you, and you don't need to get your PhD for permission to do this. You can get a telescope. You can make observations. There's tons of volunteer networks that will help you out. There's tons of people that will teach you whatever you need to know, and you can be making meaningful contributions in just a couple of years.
Fantastic. Fraser, it was an honor and a pleasure. Thank you. Thank you very much. I hope you will get back to us soon.
All right, take care.